Alright, so we're going to continue with that last problem where we determine the acceleration of a block that's sliding down a ramp. We determined at the end of the problem that the value for the acceleration was 0.67 meters per second squared. So that's what we determined the acceleration as. Again, I noted at the end of the last video how the masses divided out here. I didn't really elaborate on that too much, and I'm not going to, but I just want to point out that something pretty significant is going on there in the mathematics there that implies something pretty significant. So just keep that in mind if you see something like that popping up here and then, because we will see it again. Anyway, so what we're going to do in this video is actually take the answer from our previous from the previous part of the problem to answer the following. How far will the block move in 3.5 seconds? So we drew the free body diagram, we figured out all the forces, and we determined that the block has a certain acceleration based on those forces. Once we know that acceleration, then we can then go in and do our kinematics, the same kinematics that we learned before we started tying in the forces. And really, when you tie the forces in with the kinematics, that's what's really called mechanics, and that's the way things move around, the way things accelerate, the way things move under response or in response to forces. That's called mechanics, and really that's where we've gotten to at this point, where we can tie in our knowledge of forces to our knowledge of how those forces dictate how an object will move. Okay, so how far will the block move in 3.5 seconds? If you remember from doing those kinematics problems, the easiest way to do them is use the guess method. What are we given? What's our unknown? Things like that. I want to point out, I should have changed this. How far will the block move in 3.5 seconds if starting from rest? I should have had that before I made the video, but whatever. How far will the block move in 3.5 seconds if starting from rest? So what are we given? Obviously, we're given the time interval, which is going to be 3.5 seconds. We're starting from rest. So that implies that our initial velocity is 0 meters per second. And we're also given what we figured out in the last part of the problem, which is the acceleration. That's 0.67 meters per second squared. And then our unknown, what is our unknown going to be? Well, we're asked to find how far will the block move in 3.5 seconds. And we're moving in the positive x direction, so that's going to be a delta x. That's what we got to find. So if you remember, many years ago, when we were learning kinematics, we used these equations, right? We might have seen them in different forms, slightly different forms, but these are the four big kinematic equations. We need to match up these guys with one of these equations. And it looks like, here, we got a vi t delta x, we got a delta x, a vi, a t, an a, another t. So it looks like that's the equation that we should be using. So, in the e column, we're going to write that equation. Delta x is going to be initial velocity times time, plus 1/2 times the acceleration times the time squared. Okay. So that's the kinematic equation we want to use. Note that our initial velocity is 0 meters per second, so right off the bat we know that that term is just going to be 0. So we can just rewrite delta x is 1/2 at squared. Alright, so now we just want to make our substitutions and then solve. So we're going to substitute our values in, and we're going to get delta x equals 1/2 times the acceleration, which we figured out is 0.67 meters per second squared, times the time, which is 3.5 squared, and notice the units are going to be seconds squared as well, because we're squaring that unit also. I just moved it outside of the parentheses, so that we can see that it's going to cancel with that unit there. And when we put that in our calculator, we come up with 4.1 meters. So in 3.5 seconds, the block would have gone 4.1 meters.